We're going to continue topic 4.1 and we're going to move on to how do we solve quadratic equations. So you can use factoring to solve a certain quadratic equation. A quadratic equation in one variable can be written of the form ax squared plus bx plus c equals 0, where a does not equal 0. This is called the standard form of the equation. The solutions of a quadratic equation are called the roots of the equation. If the left side of ax plus bx plus c equals 0 can be factored, then the equation can be solved using the zero product property. All right, and then the standard form of the quadratic equation, not sure why we're writing again. We already had it there, but we've got to write it again. Bx plus c equals 0. So really what they're talking about here is, hopefully you know that their quadratic equation is a parabola, or looks like a parabola, okay? Let me draw that in a different color. What we're talking about is where the solutions to it are where it crosses the x-axis, which means those are zeros. We also call them roots. We also can call them solutions. So the reason it's called zero product property is it ends up being the product where the y value is equal to 0. All right, so in words, if the product of two expressions is 0, then one or both of the expressions equals 0. If we did this in algebraic look, if a and b are expressions and a times b equals 0, then either a equals 0 or b equals 0. If we did this algebraically, so basically this is already the factored form, then it means that either x plus 5 equals 0 or x plus 2 equals 0. And if we went to solve that and subtracted the 5, we would get -5. Or if we subtracted the 2 from this, we would get -2, would be our solutions. So let's try a few of these. We're going to do a good old magic x. So magic x, two numbers that multiply to -15 and add to -2. So that would be -5 and 3, I think. So that would give us x minus 5 times x plus 3 equals 0. Now I'm going to use the zero product property to split them up and set them both individually equal to 0. So we get x equals 5 and x equals -3. I could check these by putting them back in to see if they actually worked. All right, let's try again. So I'm going to use a magic x again on example 18. It looks like I've got a -24 in the top and a 10 in the bottom. So I'm looking for two numbers that multiply to -24 and add to 10. So 12 and -2, I think. I'm going to get out the box because I have a leading coefficient. So in the top left-hand corner, I'm going to write 3x squared. In the bottom right, I'm going to write -8. Then I'm going to follow that by my numbers from my magic x. So 12x and -2x. I'm going to ask myself, what two numbers equal or multiplied together equal 3? And so, or what times what equals 3? That's got to be 3 and 1. I know my 3 will divide my 12, my 1 will divide anything. So 3x divides 12x 4 times. 1x divides -2x, -2 times, and then I check it, -2 times 4 is -8. All right, I'm going to write that out as x plus 4 times 3x minus 2 equals 0. We're taking this all the way though because we've got the equals 0, so I have to use the zero product property to split it up and set each factor individually equal to 0 and then solve those. So I subtract the 4, I get -4. I add the 2, I get 3x equals 2. I divide by 3, I get 2/3. So my solutions are x equals -4 and x equals 2/3.